Hello, I am Jarno Verhagen and I'm a PhD candidate at Ghent University and I'm going to present PowerShap, a powerful Shapley feature selection method. Feature selection is a core part in the machine learning pipeline as it reduces dimensionality, reduces training times and often increases performance. There are two methods to do this. There are wrapper methods that train a model and use a metric to select features, and there are filter methods that use data analysis to select features. Wrapper methods are generally strong, but they have a large computational complexity. Filter methods, on the other hand, are generally fast, but they impose assumptions, require hyperparameter tuning, and have no model interaction. Therefore, we developed PowerShap, which is actually a combination of these two methods. And it is built on the hypothesis that the impact of a known random feature should be on average lower than any informative feature. To do this, we use the SHAP library to evaluate impact. We use multiple iterations to get an average and use statistical analysis to test the hypothesis. Practically, in implementation, we first add a known random feature to the dataset. We then split it into training and validation sets to then train a model, can be any model, and use a SHAP explainer on the validation set to get the SHAP values. And we then take the absolute and then the mean SHAP value per feature. We repeat this for a couple of iterations to get multiple mean SHAP values per feature, on which we then do the statistical analysis to get the final feature set. However, this requires setting a required amount of iterations. And we developed an automatic mode that can automatically determine the required amount of iterations. As such, there is no hyperparameter to tune. And in automatic mode, we use power calculations. And the reverse of the power calculations of the statistical test can actually give us the required iterations to get the perfect feature set. And we use these numbers in automatic mode. If we evaluate PowerShap on a simulation dataset of 5,000 samples and varying amount of features and varying amount of informative features, we can see that PowerShap has a very fast execution time and finds almost all to most informative features without outputting many noise features, outperforming state-of-the-art methods. If we do this on benchmark datasets, we can see the same with a lower execution time for PowerShap and the same performance. This code snippet also shows how easy it is to use PowerShap in pre-processing pipeline. And if you're interested for more, go scan the QR code to go to the GitHub and read the paper, or feel free to send me an email. Thank you for listening and see you at the conference.